And here we are. It is 4 p.m. Central European Daylight Time. Thank you so much for joining to this presentation about Airlock Microgateway 2.1. My name is Adrian Kosmaczewski. I'm developer relations at Vision, the DevOps company in Zurich. I'm in Zurich, so hello every one of you who are joining from anywhere in the world and who are watching this from wherever you are, or if you're watching this from YouTube afterwards, thanks for joining. And if you're watching this on YouTube, please hit the subscription button and the notification icon, of course, in our channel vision.tv. Joining me from Ergon, the company behind Airlock, I have tonight with me the pleasure of having Daniel Esterman, Martin Burkhardt, and Stefan Dietiker. So thank you so much for being there. They will be as well available for questions later on, which, as I mentioned, in terms of questions, for those of you attending live, if you have any questions, there's a Q&A box on your Zoom window. So please feel free to write your questions there. We're going to be answering them at the end of the presentation. Okay, this should only take about 40 minutes of your time. And we're going to be talking about Airlock Microgateway 2.1, one of the key products in the Airlock portfolio that makes your cloud native applications much safer. Just a little bit of advertising about Vision, the company I work for. The name first, of course, how do you pronounce it? It's pronounced Vision, like the vision, hence the I in the logo. We are the DevOps company located in Zurich. We started our activities in 2014. We are 46 Visioneers now in Zurich, and we're the leading DevOps, Kubernetes, and Docker partner for many companies who need 24/7 support for their cloud native applications. We are certified in various ways, which are very important for many of our customers. And of course, we are very proud of having been the first Swiss company that has been certified, Kubernetes certified service provider. We are partners with a large array of companies very active in the cloud native space. You can recognize I'm pretty sure you can recognize many of the names on this slide. But of course, tonight we're going to be talking a lot about Airlock. Three more things. We are at Vision as well. We develop a few products. We have a Puyo, our own platform as a service offering based on OpenShift and Rancher. And we offer open source projects like Project Sin and KDAP that are targeted for the maintenance of Kubernetes clusters. So please check them out on GitHub directly on our website, vision.ch. But enough about Vision, because this is not the point of this webinar, of course. We're going to be talking about Airlock and Airlock Microgateway. And Airlock Microgateway fits in a larger spectrum around DevSecOps and Zero Trust. So we're going to be talking about that and why it is important. We're going to be talking about Airlock Microgateway 2.1 and how it helps you fulfill your needs for DevSecOps and Zero Trust security. We're going to have a little bit of a demo. I'm going to show you how to secure a very sloppy application that we have to secure somehow, and it's running on the web. So we are open for attacks, and we don't want that. So we're going to be taking a few steps to make this application more secure. And at the end, of course, if you have any questions or answers, we're going to be very happy to help you and provide answers for those questions. So first of all, let's talk about DevSecOps. Everybody knows DevOps, and lately a lot of people are talking about either DevSecOps or GitOps. In this case, we're going to concentrate on DevSecOps. And DevSecOps is basically the application of the DevOps principles to the world of software security and application security. Which are the three principles of DevOps, the three main guidelines of DevOps? The first one is, of course, the principle of flow. Usually in the DevOps parlance, the principle of flow means that your teams are continuously improving, adding new features and correcting features, correcting bugs on your applications. In the case of security, in the case of DevSecOps, the principle of flow means that you are going to continuously proactively harden your applications. You're going to make them more secure as time goes by. This is a continuous process going on and on and on. The second important principle of DevOps is feedback. In the case of a normal application, of course, in the normal case of DevOps, in the usual case of DevOps, the principle of feedback means listening actively to your customers. So you can include that feedback in the principle of flow and create new features and solve bugs thanks to the feedback of your users as they use your application. In the case of DevSecOps, of course, this has more to do on keeping an eye open on threats. So being all the time alert, learning what's going on, reading the logs of your application, monitoring your applications, seeing if there are unwanted visitors that are trying to knock at the doors of your login page, and so on and so forth. All of this is part of the second principle of feedback. The third principle of DevOps is continual learning and experimentation. And this is a very human level of understanding for DevOps. This is how teams can get better over time. And in the case of DevSecOps, this means having your teams proactively evaluate everything that's going on and then having retrospectives every time something happened, every time you have a security breach, every time you have a security problem, to create the proper documents, to leave a trace of all the actions that you took to solve those problems. This is part of the continuous learning of your DevSecOps teams. So the three principles of DevOps, remember, flow, feedback, and continuous learning. And of course, they have a very, very specific meaning in the world of DevSecOps. Another thing we are hearing a lot these days in security circles, of course, is zero trust. Zero trust right now is being pushed as a series of three basic principles that help teams harden their applications and make them more secure by default. The first of these three principles is the explicit verification. This means that you're always going to authenticate and authorize based on all available data points, including user identity, location, device health, service, workload, and so on. At any given time, you're verifying all of the inputs and all of the users of your application. You are going to provide your users with least privilege access. So this means that you are going to use just in time and just enough access. You're going to have risk-based adaptive policies, and you're going to use data protection to protect both the data and what the data is being used for in your applications. And of course, you've got to be a little bit paranoid because it's a dangerous world out there. So you have to assume that your application is going to be attacked. So that means that you have to minimize the radius of exposure of your application to prevent lateral movement, to segment access by network, by user and by users, by devices, by applications, and so on. This makes the surface attack of your application smaller. And of course, it helps to reduce the risk of being attacked. It doesn't mean that you're going to eliminate them completely, but these are risk management measures that you have to take. So this is zero trust, explicit verification, least privilege access, and breach assumption. Of course, Airlock Microgateway fulfills the need for DevOps teams, DevSecOps teams actually, to be able to provide these zero trust measures on your own software. It's a cloud-native solution, very well adapted to the new world of containers and Kubernetes that helps teams secure applications, legacy and new ones on your clusters. So it provides a series of very, very interesting features. Many of the common attacks that that your application is exposed to are very well known. So by default, Airlock Microgateway by default protects against a long list of attack vectors. This list is known as the OWASP top 10, but it's not limited to. And as times go by, the experts at Airlock are adding new attack vectors that are activated by default. So this is very important. Just by installing Airlock Microgateway 2.1, you're already protected with a long range of different attack vectors. So this is a very useful feature. Just install it and you're protected. We're going to see that during the demo, by the way. As I mentioned, it's designed for the cloud. So it runs on containers, it runs as a container, it works perfectly well on Kubernetes, it is lightweight, it is fast, and it's very seamless. So you just install it, the rest of your application is working, and the microgateway is filtering everything that is going in and out from your application in real time. And this helps a lot in this new world of Kubernetes, of course. It offers some advanced features, like, for example, OpenAPI and JSON schema, which makes it a great choice for APIs. They say, I read on the web the other day, that 70% of all HTTP traffic these days is API calls. So that's a lot. That means that teams are actively creating APIs for internal use, for external use, for public, for money, open, and in many different ways, exposed to the outer world. They are created with different levels of security in mind. So for your team, it's a very good option to use Airlock Microgateway to secure those applications. The OpenAPI and JSON schema protection means that Airlock Microgateway can be configured to read the Swagger JSON definition of your API of the box, and it will automatically apply all of the filters and enforce all of the rules on your JSON schema. We're going to see a small demo of that. It's actually very useful and very easy to see how it works. It is, of course, integrated with the whole portfolio of Airlock products, and most importantly, with IAM, Integrated Access Management from Airlock. So, of course, if you manage your users and your groups and your permissions through IAM, Airlock Microgateway will automatically read all of that information for you and will be applied. And of course, that simplifies the development and the design and the deployment of your application greatly. There's many authentication checks, including JSON Web Token validation. And of course, because we are talking about the DevOps approach, it's the DevSecOps approach. After all, we are talking about storing all of this information in text files. So it's security as code. Just like you have infrastructure as code, here we are talking about security as code. And you can store all of this information very easily on your Git repository, which makes it a very good option to ensure the security of your applications through a continuous integration and continuous deployment pipeline, for example. In terms of the built-in OWASP rules, this is just an extract from the official list. The full list, you can see it on the bottom in the docs.airlock.com, which is the official URL for all the documentation of all of Airlock products. But of course, you've got the common culprits, you know, SQL and NoSQL injection, cross-site scripting, HTML injection, and so on and so forth. There's a lot of built-in protection already ready for you and in use the moment you install it and the moment you start using it. Which are the common use cases for Airlock Microgateway? Well, of course, if you're doing microservices, it's a great option because you can have one or many instances of Airlock Microgateway in front of in every one of your microservices, enforcing different levels of security in different ways for each one of your services. So it's can be tuned very finely grained in a very finely grained way. And you can this way create architectures that are very scalable, but at the same time, very secure. However, not everybody is doing microservices. Of course, there's a lot of monoliths out there in the world. So of course, Airlock can be used with monoliths. And actually, the example I'm going to show, it's a very simple, very small monolith, but it's still a monolith. And we're going to use it to protect it a little bit. Of course, because it's so lightweight and it's so easy to install, you can use it locally on your own computer, and which is exactly what I'm going to do in my demo. My demo is running on a Minikube cluster, For those of you who are watching, I'm pretty sure you know what it is. What is Minikube? It's a very small Kubernetes distribution that runs on your laptop. So I'm really using Microgateway directly on my Minikube as if it were a normal or bigger Kubernetes cluster. And at Vision, we've used Airlock Microgateway on Exascale, for example, or on OpenShift, and it works exactly the same. So you've got the same experience on your laptop as in production, which actually helps a lot developers to get their code right and to know how to interact with Microgateway and all of the rules that are enforced by Microgateway. So this is a great thing as well. As I mentioned, this is the typical layout you would use Microgateway. You could have for each one of the pieces of your cluster, each one of the services in your cluster, you can have an instance of Microgateway with its own configuration that basically allows or disallows certain types of traffic. And of course, everything can be integrated with other products from the Airlock portfolio, which is, for example, IAM, which I just mentioned, or the Airlock Gateway. So all of these works together really, really well and can give you a very unified solution for your security so that you can only concentrate on the business logic of your application. Airlock Microgateway comes in two versions. One of them is free, just install it and use it, no questions asked. And the other one is premium with a cost, a license cost. The biggest difference between both is, of course, the support. In the case of the community edition, you get community support with a forum. In the case of premium support, you can have access directly to the know-how of Airlock engineers to solve your problem. So, of course, this is a great value added. In terms of features, they are pretty much the same until you reach some advanced protection features and the integrated access control features. In those cases, the community edition will only log whenever it detects a breach or a problem, but it will not block those requests. Of course, the premium edition will do this. One of the advanced protection features is, of course, the OpenAPI integration, which I think is one of the great features of Microgateway, and we're going to see that today in the demo. So if you have an API, and if you have a Swagger definition, and who has an API with a Swagger definition anyway these days, you can just literally feed the Swagger definition to Microgateway, and Microgateway will immediately enforce all of the rules into of all the traffic going in and out of your API. So this is great. So this is one very good value added for your product. Very good. So all of this is a lot of blah, blah, but I think the best way for you to see how good Airlock Microgateway is to actually see it in action. So what we're going to basically do in this demo is to secure a problematic app. We all have these kind of apps because, you know, technology has advanced so quickly in the past 20 years. Everybody has these old apps built maybe with PHP or C# version 1.0 or 2.0. They haven't been updated in, let's say, 15 years, but they are still very useful, but they show a little bit their age. They are not exactly compliant with the latest fashion in security. And of course, they can be exposed to new threats that we were not aware of back in those days. So we're going to enable Airlock Microgateway on a small Minikube cluster, and we're going to protect this application. And we're going to see how just by activating it, we are already protected from a lot of problems. And this is great. Then we're going to extend it because actually our app has some custom problems, some things we wouldn't like to show to the world, right? And we're going to try to use Microgateway with some custom rules to prevent those problems from happening. And at the end, we're going to use this great OpenAPI support because yes, the application is an API. It is a small API. It's a web application that has an API actually, and it responds XML and JSON as you would expect. And it has an OpenAPI, a Swagger definition. And we're going to literally give this Swagger definition to Microgateway and immediately we are going to see the change in the behavior from the outside world. We're going to see that the rules in OpenAPI, in the OpenAPI definition, are going to be enforced immediately. The demo is extremely simple. It's extremely simple. We've got on our cluster, we have an application called Fortune. Fortune is an old application written in C# back in the days. It spits XML because Microsoft is very fond of XML, or at least was very fond of XML back in the 2000s. And of course, a little bit of JSON as well. And it has a little bit of a clunky user interface where you can enter a little bit of information. And right now, the default installation of our application, we have the ingress of our cluster directly talking to the Fortune service. And the Fortune service has behind it, we have 4 instances of the application for scalability. So we have 4 instances of the app running at the same time behind. What we're going to do is, of course, to cut this direct connection. And we're going to go directly from the ingress to Microgateway. And then Microgateway will let or not traffic to our Fortune application. So let me please show you, let me just show it to you in action. So here you can see the application. It's a very simple application. It's actually, it has a style like from the 2000s. It's a little bit, it's reminiscent of the style of the web apps in the 90s. We are not yet in Web 2.0. So you can say that this is circa 2005, 2006, but it's actually a nice application. You get you know, for example, you get Fortune cookies, and people love this application. We've got people, you know, creating TikTok videos with Fortune cookies. So clearly, we've got a lot of traffic here, and this has a lot of potential. The application is a bit old, so if I refresh it, I can see new Fortune cookies. And actually, the application is live right now on this URL, microgateway.eu.ngrok.io. So for all of you watching this application, watching this presentation live, you can go now directly and use your browser and play with this application. So this application basically provides a cookie. Every time you refresh, you get a different cookie with funny messages, anecdotes, quotes from famous people. And one thing you can do is, for example, you can here write your name and hit the send button. And of course, you've got a customized message for you, Joe. But of course, as you can see, I've already been playing a little bit with this application. It has a little bit of problems. So for example, it's basically, it can basically suffer from cross-site scripting injection. So I can actually inject scripts. So this was wrong. This was the wrong. I forgot the style element in my JavaScript, and boom, I can actually inject an alert if I want as well, and boom, I have my alert showing up. So clearly, this is not very good. Actually, more worryingly, is that I can actually inject SQL. And this is not very good. We don't want to have this kind of things, because somebody could erase the database of all the Fortune cookies. And we've been adding Fortune cookies to this application for ages. We don't want to lose all of that investment. So clearly, this is not working very well. So let's go a little bit to the code of this application. Yes, and before I show you more, of course, this application can be used on the command line as an API. So here, for example, if I curl on the same URL and I can pass a parameter, I can have a Fortune cookie for that name on plain text format. So here I have to specify that I accept text plain. I can also specify that I accept application XML, in which case I get something that would make Bill Gates very happy. And here I can get some JSON, which would make Douglas Crockford very happy. But as you can see, it's a very flexible thing. I get a little bit of flexibility. However, I don't know if you notice, but the URLs are not exactly the same. So here I can, to get the plain text version, I can curl directly on the root, while, and this is not what I wanted, and here to get to talk to the API, I have to curl to the API itself. Okay, so it's /API, while this one is on the root. So small differences here and there, because yes, this application exposes a Swagger definition. So I'm using, this is a .NET app. .NET has one of these beautiful features that it basically builds automatically the Swagger for you. And here is the Swagger. This is the JSON. This bit of JSON defines our API. And of course, it defines exactly what the API should do. And here, the only path exposed by my API is the /API, is the only path that I'm exposing right here. So clearly, we have here something that looks like an API. In this part of the screen, I have something that looks like an API. It spits plain text, but it's not part of the API, right? I mean, officially, my Fortune get /API only supports XML and JSON. So there's a little bit, it's not very intuitive to know where you should send the request to. It's a bit confusing. That can happen sometimes. Let's put a little bit of order into all of this. The first thing I have to do, of course, is to enable microgateway. So in my cluster, and I can go directly to my K9S instance. So here you can see the four parts of my Fortune application. They are responding messages. If you are using the application right now, this is where the information comes from. And I have my microgateway installed, but not yet in action. Because right now, if I look at my ingress is directly talking to Fortune-service. And Fortune-service is the load balancer that we had created when we moved this application to Kubernetes a couple of years ago. Actually, what we need to do at this point in time is to, there we go, instead of redirecting traffic to the Fortune service that listens on port 9090, I'm going to send my traffic to the microgateway service that listens on port 8080. And this is the only change I need to do at this point right here. And of course, this is where things sometimes, this is this is annoying. I will relaunch this window again. This is what happens when you do demos live. There we go. Somehow this session disappeared. I should be able to basically see everything again and save. Very good. So that's good. So now that I've saved my ingress and my ingress is now talking to the microgateway service, of course, what I need to do is to apply those changes. So I'm just going to use the good old kubectl apply -f deployment. The deployment is a folder where all of my YAML files are located. And of course, if I look at the ingress, I have configured my ingress. And that means that from this point on, if I try to do one of these things, automatically I get a bad request. I didn't have to do anything else than configure my ingress to talk to microgateway. Everything else is done directly for microgateway. My application is now protected from script kiddies. So for example, you have somebody who really wants to change the background color of my application, it's a bad request. It doesn't work. If somebody wants to inject SQL, it's a bad request, and so on and so forth. I get all of this for free just because I'm using microgateway. So this is a great, great, great added value for my application. So this is great. However, our application has a little bit of a problem, actually. It has we had a developer that was actually very funny, and this developer left what is it called? An Easter egg. Easter eggs. You could go to Excel back in the 90s. You would type a certain sequence of keys on your keyboard, and you would get a flight simulator. And this is an actually thing. It was actually true. I remember that in Excel 4 or Excel 5 back in 1990 something. We don't want this. Actually, the Easter egg here is Smurfs. So basically, if you enter the word Smurf on a request, you're going to have this little thing coming up, which is you've been smurfed. And we have this new policy in our company. We don't allow this kind of and it works actually in all the forms of the word smurf. You can send Papa Smurf or you can send Smurfette, and you will get the same result. Many companies have this policy of not accepting Easter eggs because, image and security reasons and so on. Actually, Microsoft forbid these Easter eggs back in the 90s, and they're not allowed anymore. So we don't want to have this anymore on our application. So how are we going to solve this problem here? Well, we can use Airlock Microgateway for this. And for that, we need to change the configuration of our microgateway installation. So there are plenty of files in our to get microgateway to work. You actually use a standard Kubernetes deployment to install these. And one of the things that uses microgateway, it's an init container. The init container is the one that reads the configuration from this /config YAML. And this configuration is specified on a config map, which is a very standard way for this kind of configurations to be included in your gateway. And of course, we have config.yaml. Config.yaml is it's exactly what we need here is a configuration of our. And of course, because I had to reload this, I've lost the configurations that I wanted. So I'm just going to go back right here. And I'm going to undo these changes. And I'm going to just copy them from right here. Very good. There we go. There we are. So this is what I wanted. This is what I wanted to show. We are going to extend the configuration of our microgateway to block Smurfs. This is exactly what we want at this point in time. So we don't want to have Smurfs. And how do you identify something that has a Smurf, a request that has a Smurf? It's a request who has a parameter with the pattern Smurf. So this language is actually documented and very well documented on the Airlock documentation website. So here it's a very simple example. Any request that has the name Smurf will be blocked. And here I have to, I can remove this. And here what I can do is to add this rule group that I just created called block Smurfs to the rules that will be applied to my microgateway instance. So once I've done this and I've saved the files, what I can do is, of course, to apply the changes again. And this will, of course, reconfigure the configuration of my microgateway config. Now, at this point in time, in the current version of microgateway, the changes to the configuration are not picked up automatically. This means that if I type Smurf, right now, the application is still allowing Smurfs to run, even though we have applied this new configuration. What we have to do is to delete the pod. I will literally delete the microgateway pod, and because it is part of a deployment, Kubernetes will ensure that there is the number of instances of our pod running on this cluster, and this will take around 30 seconds. It will reread, the init container will reread the configuration, will set up everything internally as it should be, and we are going to have at the end a microgateway instance with the new configuration, which is exactly what we want. So here it is. It's actually starting, still not ready. It usually takes a few seconds. Around 30 seconds in my machine at least, which is a 2018 ThinkPad running Linux. And this will, let's see when it is ready. Let's wait for a few more seconds. And there we go. So now we have one instance ready. So that means that now if I try to send a request with a Smurf, I get a bad request. So we are effectively blocking people from using the application in ways that we do not want, but they can still get, you know, your fortune cookies. So we make sure that all of those influencers on TikTok or Instagram are able to use the fortune cookie application, and we get lots of traffic thanks to them. But we do not want to have the Smurfs on our screen. That's basically what we want right here. Good. The third thing I'm going to show now in the demo is the integration with Swagger UI. So this is a Swagger, the JSON that represents our OpenAPI specification, right? And what I'm going to do, which I have already done right here, as you can imagine, it's already to integrate on my config map the whole of this Swagger JSON specification. It's literally a copy paste. I haven't touched it. I haven't modified it in any other way. I've just formatted this in such a way that it's valid YAML. But the contents of these API are exactly the ones that you see on the screen. So here, that you see on the browser. So this is exactly, and this is very useful because now on my config YAML, I can enable this API security section right here. This API security section, what it does is to take the specification of your Swagger file and to apply those rules directly on the screen. Okay, so this is very, very useful. And we're going to see one case where this is actually very happy. I'm going to go back before I deploy this API. I'm going to zoom this guy, which is the one that accepts JSON. And what I'm going to do right here is to see that if I use one letter on my name, or if I use a very long text as the name, they are both accepted by my API. But if I look at the Swagger UI JSON, I can see that in the Swagger UI definition, the developer has specified that there's only a max length of 15 and the min length of 3 for the name applied to an object returned by the API. So this object returned by the API is actually not valid. So what we are going to see now is that the next time I try to execute this request will be effectively blocked by Microgateway. So the first thing I have to do is, of course, to save this, and then I have to kubectl apply. So I'm going to kubectl apply all of those changes once again. My configuration has been once again changed. And if I go to my deployment, I can delete my Microgateway pod. Once again, this will take around 30 seconds. It will reread the configuration from the config file. It will reapply all the internal values as exactly as they should be. And it will reconfigure itself so that these new rules of OpenAPI will be applied to all the incoming and outgoing requests that are produced by our API. So this is very, very interesting because the developer somehow specified that metadata on the definition of the JSON, yet it is not enforced by the app. So here, Microgateway can be used as a way to enforce compliance towards that specification, which can be very useful in many, many different ways, particularly when for any reason, you don't have access to the source code of the app, which is the case here. We don't have access to the source code. So this is why we're doing all of this. So if I go now and I curl once again, on my API, and I try to get the same request as previously, now I get a 400 bad request directly on the command line. So that means that all of a sudden, this call, and actually the previous one as well, if I try the previous one with just one letter on the name, that one is blocked as well. However, if I try to use JSON as the name, I get a normal JSON response and everything works. So our API is still working. It's enforcing the rules on the Swagger UI as we need them. And another thing is that now we cannot call anymore right here on the root of the application. We were able to get text plain requests. We were able to do text plain requests on the root of the app and get a very nice thing. This is gone. Why is it gone? Because this is not part of the OpenAPI specification. The OpenAPI specification we've used, the Swagger file, does not include that URL with that payload as part of the API. Hence, it is blocked. By whom? By Airlock Microgateway, of course. So there we go. You've got an overview of how this application, and of course, this guy has been completely blocked. You cannot use anymore this one, but you can use the API, which we plan to, of course, use in our Fortune mobile application that will only use the JSON API, of course. So we're very happy about that because nobody uses web apps anymore for these kind of things. If you want to be on TikTok, you got to have a mobile app. So this is how it goes. So now we are protected against these guys, very dangerous, you know, they are getting more and more into computers. So we want to block Smurfs on our application. As a reminder, here it is how you define a custom rule. We've seen that a few minutes ago. This is the custom rule that blocks Smurfs on your app. And this is the custom configuration that you have to use Swagger API definitions, Open API definitions on your microgateway instance. So basically you have to include the Swagger JSON on the config map and then specify, tell explicitly, I want to enforce those rules as well. Of course, all of this means that your deployment has to somehow specify where are the configuration files that you're looking for, in this case, Swagger JSON and config YAML. The values, the paths, of course, are the ones that you've specified on the config map. Very good. So that's pretty much everything I wanted to show to you today. These are the links to the Airlock Microgateway 2.1 documentation and the website. There's a community support forum. If you want to start with the community version, you can go there and see and get help from the community. You can check out the website from Ergon, who are the people behind Airlock. They are doing this great job and this great product. And for those of you who are really interested in this subject, please go check out the OWASP Top 10 Security Vulnerabilities. They are all in this website at the bottom in this page. Thank you so much for watching this presentation. I hope this was useful, that this will give you, this will give you the idea of actually starting to play with Airlock Microgateway, install it in your own premises, maybe starting in your laptop, then in your test or quality assurance cluster to see how these rules and how flexible the language of definition of the rules is, because there's a whole language with plenty of possibilities. You can define very, very, very interesting custom rules for your application. And of course, if you have any questions, please write them on the Q&A box. Right now, I'm going to take a little bit of a look to see if we have something. We have no questions right now. I will wait a few more seconds for you to write questions. In the meantime, my data, my coordinates are on the screen. Feel free to drop me an email if you would like a custom demo of Microgateway, if you would like to know more about it. And of course, you can always contact the awesome team at Ergon and Airlock. They're doing a great job. Check them out as well. And yes, thank you so much for watching this presentation. So the YouTube video stops here, but we continue live. So if you weren't live in the presentation, you don't get the possibility of seeing the questions that have been asked. And I see somebody in the chat as well. Great presentation, thank you. Thanks a lot, Friedrich. Thanks for attending the presentation. I hope it was useful. I don't know if somebody has any questions. We've got, of course, Daniel, Martin, and Stefan from Ergon, who would be very, very glad to add more. I don't know if you guys would like to add something to what I presented during this presentation. Please feel free to chip in and tell me as well. I hope I didn't make any mistakes or I said anything wrong. I suppose not, but.
Well, thank you very much. I think it was a great demonstration of capabilities. So thanks a lot.
No problem. My pleasure. Now it's a very fun, just to tell you the story to those of you watching this right now. One of the secrets, I knew nothing about Microgateway at the very beginning. So Stefan sent me a lot of information, a lot of links. I went directly to the documentation and he told me, you know what, if you have any questions, just pop in. I said, okay. I went to the docs. I learned how it works. The documentations are fantastic, very well written, lots of details, lots of examples. And I basically could get this demo running very, very quickly. So seriously, try it out. You've got a community version that you can actually use without charge. So I think it's an awesome product that you can use in your cluster for ensuring the security and the zero trust of your payloads. I would of course recommend it. Cool. Well, I see there are no questions in any case. So in that case, it is 16:45 Central Europe Standard Daylight Time in Zurich. Thanks a lot for watching. I hope you enjoyed the presentation. Thanks to the people from Ergon and Airlock for a great product and great documentation. And yeah, see you soon in another webinar. Bye-bye.